Download this code from codegive.com, link in the description below. Using GPU shaders is an essential part of modern graphics programming, allowing you to perform complex computations and rendering tasks efficiently. Shaders are small programs that run on the GPU and are typically used for rendering graphics, performing computations, and creating visual effects. This tutorial will cover the basics of using GPU shaders, focusing on vertex and fragment shaders, and will include a simple code example using OpenGL and glsl, OpenGL shading language. Prerequisites: 1. Basic knowledge, familiarity with graphics programming concepts and C/C++ programming. 2. OpenGL setup, you need an OpenGL context setup. This can be done using libraries like glfw for window management and glew or glad for managing OpenGL extensions. Understanding shaders. 1. Vertex shader, this shader processes each vertex's data, including its position, color, and texture coordinates. It transforms the vertex's coordinates from object space to clip space. 2. Fragment shader, this shader processes the data for each pixel, fragment, that will be drawn on the screen. It handles color, lighting, and texture mapping. Basic shader code example. Here's a simple example that demonstrates how to use vertex and fragment shaders with OpenGL. Step 1, Vertex shader. Create a file named vertex_shader.glsl. glsl. Version 330 core. Layout, location equals 0, in vec3 oppos, / vertex position. Layout, location equals 1, in vec3 a color, / vertex color. Out vec3 our color, / output color to the fragment shader. Void main. gl_position equals vec4, oppos, 1.0, / transform vertex position. Our color equals a color, / pass color to fragment shader. Step 2, Fragment shader. Create a file named fragment_shader.glsl. glsl. Version 330 core. In vec3 our color, / color from the vertex shader. Out vec4 frag color, / output color. Void main. Frag color equals vec4, our color, 1.0, / set the output color. Step 3, Setting up OpenGL in C++. Here's a simplified version of how to set up OpenGL and use the shaders. CPP. Include gl/glue.h. Include glfw/glfw3.h. Include iostream. Include fstream. Include string. gluent compile shader, const std string and source, glenum type. gluent shader equals gl create shader, type. Const char *src equals source.c_str. gl shader source, shader, 1, and src, null pr. gl compile shader, shader. / check for compilation errors. Int result. gl get shader of, shader, gl_compile_ status, and result. If, result equals gl_false. Int length. gl get shader of, shader, gl_info_log_length, and length. std string error, length. gl get shader info log, shader, length, and error 0. std ser failed to compile shader, error std and l. gl delete shader, shader. Return 0. Return shader. gluent create shader program, const std string and vertex shader source, const std string and fragment shader source. Gluent program equals gl create program. Gluent vertex shader equals compile shader, vertex shader source, gl underscore vertex underscore shader. Gluent fragment shader equals compile shader, fragment shader source, gl underscore fragment underscore shader. Gl attached shader, program, vertex shader. Gl attached shader, program, fragment shader. GL link program, program. GL delete shader, vertex shader. GL delete shader, fragment shader. Return program. std string read file, const std string and file path. std if stream file, file path. If, file.is underscore open. std ser could not open file, file path std and l. Return. Return std string, std is streambov underscore iterator char, file, std is streambov underscore iterator char. Int main. // initialize glfw. If, glfw init. std ser failed to initialize glfw std and l. Return -1. // create a windowed mode window and its OpenGL context. glf window asterisk window equals glfw create window, 800, 600, OpenGL shaders example, null pr. If, window. std ser failed to create glfw window std and l. glfw terminate. Return -1. glfw make context current, window. // initialize glew. Glew experimental equals gl underscore true. If, glew init, equals glew underscore ok. std ser failed to initialize glew std and l. Return -1. // define triangle vertices and colors. Float vertices equals // position / colors. -0.5f, -0.5f, 0.0f, 1.0f, 0.0f, 0.0f, / vertex 1, position, x, y, z, and color, r, g, b. 0.5f, -0.5f, 0.0f, 0.0f, 1.0f, 0.0f, / vertex 2. 0.0f, 0.5f, 0.0f, 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 1.0f / vertex 3. / create vertex array object and vertex buffer object. Gluent VAO, VBO. GL-gen vertex arrays, 1, and VAO. GL-gen buffers, 1, and VBO. GL-bind vertex array, VAO. GL-bind buffer, GL underscore array underscore buffer, VBO. GL buffer data, GL underscore array underscore buffer, size of, vertices, GL underscore static underscore draw. / specify the layout of the vertex data. GL vertex attrib pointer, 0, 3, GL underscore float, GL underscore files, 6 asterisk size of, float, void asterisk, 0, / position attribute. GL enable vertex attrib array, 0. GL vertex attrib pointer, 1, 3, GL underscore float, GL underscore files, 6 asterisk size of, float, void asterisk, 3 asterisk size of, float, / color attribute. GL enable vertex attrib array, 1. GL bind buffer, GL underscore array underscore buffer, 0, / unbind VBO. GL bind vertex array, 0, / unbind VAO. / load shaders. std string vertex shader source equals read file, vertex underscore shader.glsl. std string fragment shader source equals read file, fragment underscore shader.glsl. gluent shader program equals create shader program, vertex shader source, fragment shader source. / main loop. While, glfw window should close, window. / render. GL clear, GL underscore color underscore buffer underscore bit. GL use program, shader program. GL bind vertex array, VAO. GL draw arrays, GL underscore triangles, 0, 3. GL bind vertex array, 0. / swap buffers and poll events. glfw swap buffers, window. glfw poll events. / cleanup. GL delete vertex arrays, 1, and VAO. GL delete buffers, 1, and VBO. GL delete program, shader program. glfw destroy window, window. glfw terminate. Return 0. Explanation of the code. 1. Shader compilation. The compile shader function compiles the vertex and fragment shaders, checking for errors during compilation. 2. Shader program creation. The create shader program function links the vertex and fragment shaders into a shader program. 3. Vertex data. The vertex data for a triangle is defined, including positions and colors. 4. VAO and VBO, vertex array objects, VAOs, and vertex buffer objects, VBOs, are created to store vertex data. 5. Rendering loop. The main loop clears the screen, uses the shader program, binds the VAO, and draws the triangle. Conclusion. This tutorial introduced you to the basics of using GPU shaders in OpenGL. You learned how to write vertex and fragment shaders in glsl, compile and link them in a C++ program, and render a colored triangle on the screen. This foundational knowledge can be expanded with more advanced techniques, such as textures, lighting, and post-processing effects. Further reading. 1. OpenGL documentation. Familiarize yourself with OpenGL functions via the official documentation. 2. GLSL reference. Review the GLSL specifications and built-in functions. 3. Advanced topics. Explore topics like geometry shaders, compute shaders, and shader optimization techniques.